We are back to do another example of solving a matrix equation. All right, so our example is the equation 2x minus y equals 10, and 3x plus 5y equals 2. So just as before, we're going to start by first writing this as a matrix equation. So we have our coefficient matrix 2, -1, 3, +5. And then we have our variable matrix, x comma y. And finally, our solution matrix, 10, 2. Our first step is to find the inverse of A. So find A inverse. So I'm going to begin by augmenting our matrix with the identity. So 2, -1, 1, 0, 3, 5, 0, 1. All right, so it looks like I can use this -1 to eliminate the 5. So I'm going to do, first I'm going to label row 1 as our pivot. For our second row, I'm going to do row 2 plus 5 times row 1. So 5 times 2 is 10. 5 times -1 is -5. Then plus 5 plus 0. And then we have 13, 0, +5, +1. And then 2, -1, 1, 0. Now, since I have gotten to a place where I have a number and 0 in the second row, I want to make this 13 into a 1. So I'm going to multiply 1 over 13, row 2. That will make, essentially, I'm dividing each of these numbers by 13. I can't really divide a row by another row or by a number, but I can multiply to create that same effect. So I'll have 1, 0, then 5 13ths, and 1 over 13. Our first row stays unchanged. Knowing that I now have a denominator of 13, I am going to make this 1 13 over 13 so that I have a common denominator in advance of needing it. And what I can do now is use the 1 in our first component of the second row to eliminate the 2 in the first row. So I'm going to do row 2 minus 2. Hold on a moment. It's really row 1 minus 2 times 2. I apologize for that snafu. I'm glad I caught it quickly. So it'll be minus 2 minus 0 minus 10 over 13 minus 2 over 13. Then we'll have 0. -1 minus 0 is still -1. And then we'll have 3 over 13 and -2 over 13. In our second row, we have 1, 0, 5 over 13, and 1 over 13. We're getting really close to finishing this one. The next step is we want to do two things, and I'm going to do them at the same time. So first, I'm going to do negative row 1 so that we can change the sign. And then I'm going to switch row 1 and row 2 so that we have our 1 in the first position. So I'm going to write our second row, 1, 0. That should be a 5. So 5 over 13, 1 over 13. And then I'll do the second one in purple since we're multiplying it by -1. We have 0, positive 1, then -3 over 13, and positive 2 over 13. And so now that we have reduced the left-hand matrix A to the identity, the matrix on the right is the inverse. So our next step is going to be to use A inverse to find X. So in this case, we really have A inverse times B. So A inverse is 5 over 13, 1 over 13, -3 over 13, and 2 over 13. And I need to refresh my memory what B is. So B is 10, 2. So B is going to be 10 and 2. Let's be interesting here and use a new color. So we're going to have 50 over 13 plus 2 over 13. This is equal to 52 over 13. And if I'm not mistaken, this reduces to 4. Let's see, 52 divided by 13. Yes. The reason why I remember is 52 is the number of cards in a standard deck of playing cards. And each suit has the numbers 1 through 10 and a jack, queen, king. Understanding playing cards like that will come up in our unit on counting and probability. Next, we have 10 times -3 over 13, which is going to be -30 over 13, and then plus 4 over 13. That gives us -26 over 13, which reduces to -2. So our solution is as a matrix, xy is equal to 4, -2. And that is the end of our question. Obviously, we could go back and check. So 2 times 4 is 8, minus -2 would be positive 10. 3 times 4 is 12, plus 5 times -2, that's minus 10. So 12 minus 10 is 2. So it checks out. We have completed this example. We'll do one more example in the following video of a 3 by 3 matrix, and then we'll be finished with this lesson.